What if you could build large-scale structures, like custom furniture or even emergency shelters, using a team of tiny, autonomous robots? Welcome to Summarize Science, where we break down the latest research. Normally, digital fabrication is limited by the size of the machine. You can't print something bigger than your printer. This means building at human scale often requires giant, expensive equipment or a lot of manual assembly. To solve this, researchers have developed a new system for what they call hierarchical discrete lattice assembly. The core idea is to use small, mobile robots to assemble structures out of interlocking building blocks. Let's break down how it works. First, you have the building blocks themselves. They aren't just simple cubes, they're made from a specific geometric pattern called an octet lattice, which makes them incredibly strong for their weight. Instead of having the robots handle tiny individual parts, these parts are first pre-assembled into larger, compounded blocks to speed up the process. These special blocks are designed to be self-aligning and connect with a simple, reversible snap fit. This is crucial because it means the robots don't have to be perfectly precise. The blocks help guide themselves into place. Next, you have the builders, the modular inchworm lattice assembler robots, or MILBs. These robots are designed to crawl over the surface of the lattice structure they are actively building. This ingenious design means the potential size of the structure is no longer limited by the robot's reach. So how do these robots know what to build and where to go? That's managed by a digital twin, a live computer simulation of the entire process. The software takes a 3D model, breaks it down into the voxel blocks, determines the best build sequence, and plans the most efficient path for each robot to take. To prove the concept, the team put the system to the test. They demonstrated the entire workflow, from a 3D model to a physical object, by building a small bench. They even showed two robots collaborating on the same structure, handing off blocks to one another. The final bench was fully functional and strong enough to support the weight of two people. This shows the real-world potential of building sturdy, human-scale objects with this method. So, to recap the important points, this system combines lightweight, strong, and self-aligning building blocks with small, simple robots that can crawl on the structure itself. Everything is coordinated by a smart simulation, which makes the whole process efficient and scalable. The data shows this hierarchical approach, using larger compounded blocks, offers a massive boost in assembly speed at a very low cost compared to previous systems. What could this mean for the future? This technology opens the door to automated construction systems that are adaptable, scalable, and affordable. Imagine swarms of these robots being deployed to build emergency housing, custom architectural components, or even structures for space exploration. It represents a significant step towards a future where complex, large-scale fabrication is accessible and autonomous. Thanks for watching Summarize Science.